If we take a closer look at our definition of a directional derivative, there is something that should be pointed out here. And the thing that should be pointed out here is that we're multiplying two terms together, and then multiplying two terms together, and then adding them up. Now, this sort of resembles what happens when you have a dot product of two two-dimensional vectors. So what I'm going to do is express this in terms of a dot product. Now, for one of the vectors that we're using, I'm simply going to point out that based on the angle given, the cosine of theta and the sine of theta that we have, this is better known to us as simply the vector u, the unit vector describing the direction in which we're taking our directional derivative. The other part over here is the partial derivative of f with respect to x evaluated at a point, and the partial derivative of f with respect to y at the given point. So what we're going to do is give this vector a special definition. The symbol that we use for this is going to be the following. This is known as del f, or the gradient of f. So the vector itself is referred to as the gradient of f. This symbol here with the upside down triangle is known as del. So with that in mind, please know that one of my favorite places to order food, oh yeah, right there, Del Taco. Del Taco, that's good stuff. So more generally, if we wanted to say that we have a function, if z is equal to a function of two variables, the gradient of f, is defined as, we'll call it del f of xy. That's going to be equal to the partial derivative of f with respect to x and the partial derivative of f with respect to y. Then we can extend the definition of a directional derivative a little bit by making use of the gradient. So, given a function, f, and a unit vector, u, then the directional derivative in the direction of u of f evaluated at a given point is going to be equal to the gradient of f evaluated at the given point, dotted with the vector u. Now there is additional significance to the gradient, and we'll describe that in the next video.